It's a very exciting meeting for us. We have 16 presentations filled with all sorts of good geospatial technology usage and practice. We have our agenda set to have open discussion and announcements. I'm going to switch that to be the end of the meeting, and we're just going to go right and get started with the presentations. So without any further ado, I'm going to introduce Trish Long from USDA. She's going to talk about everything we need to know about the spatial reference systems in 6 minutes. Yes, thank you.
Okay, so I got to get to the presentation here.
Give my
Okay,
I'm going to give you another second.
that's me at top. Great. All right. And so this is for
This guy.
oh
That'll turn off the projector.
or what?
That'll turn off the projector.
Oh.
Good.
Okay. All right. I guess we'll get started here. So, my name is Trish Long, and I think it was a little bit silly for me to suggest that we could actually cover this topic in 6 minutes. So I actually revised my title to What GIS Professionals Need to Know About Spatial References and Measurements. I'm really going to provide really reference slides for you. We're not going to talk about any of these topics in detail, but my first bunch of slides are references, and then we're going to get to kind of the meat of the talk. So these are the things we're going to talk about. For the purposes of this presentation, spatial reference refers to the combination of coordinate system and map projection. So this is what I call my first reference slide, talking real basic about what a coordinate system is. And these slides will be available for you later for reference. I have some links in here. Then what is a map projection? Again, I'm not going into this, but the key about map projections is that you're always making a trade-off between distance, direction, shape, or area. And then how do coordinate systems and map projections relate to each other? That's this slide. So that's the first section, just about the high level stuff. Here I'm going to talk about spatial references that I use in my job at NRCS, Natural Resource Conservation Service. So as a federal agency, we use the UTM spatial reference. And New Jersey is in UTM Zone 18. And again, when you use this spatial reference, you're making a choice about what's important, distance or area or direction. And this is a slide about what UTM, the distortions that it brings. Many of you working in New Jersey are probably using the state plane coordinate system. This is a slide about that and how it works across the country. And then Web Mercator, anyone who's doing web mapping would be using this. Again, this is for reference for you. And now I'm going to get into what I really want to talk about here, spatial references and measurement. And actually, let me go back. So this was really based on something that we had some folks in our office who were doing field work, and they were taking measurements, and they were noticing that they were using the Field Maps app to measure lines and areas, and then they would come back to the office. They would open up that line or area in ArcGIS Pro, and the measurements were different. And this is not something you want to see when you're expecting accurate measurements. So this is what I really want to talk about. And it required me to look into what's going on here with the spatial coordinate systems and things. So we use an app, a web app called Conservation Desktop. And it's a web app again, and it uses the Web Mercator spatial reference system. And in ArcGIS Pro, you need to know this if you don't know this, you set spatial reference when you start a new map. And or you could use the default. So the state of New Jersey's standard is the New Jersey State Plane. And most of you hopefully are using that. But then again, in my case, I was using UTM. Well, we were using UTM Zone 18. So I prepare data for our web app, the Conservation Desktop, also known as CD. And I project, or I should be projecting, all my data before I publish it to Web Mercator, because it's a web map. And then the last thing I want to point out here is that field maps is using the spatial reference of whatever your web map is, and that's going to be Web Mercator. So here's a summary of what was going on. We have three apps using two different spatial references. So we need to straighten that out. And this is just showing you what was going on. We measured a football field using field maps. We delineated the length of the football field, and then we did it in CD, and the distances came pretty close, good enough for us. And then we did the area of the football field, and again, close enough for our needs. We were happy with that. And this is a summary of that. But then when our users went into ArcGIS Pro and measured that length, they were getting 120 feet, which is wrong. Was that okay? And then they were doing the area, and it was coming like wildly different areas. So what was going on? The key is that when you're measuring things in ArcGIS Pro, you need to be aware of this term, geodesic. And here's a definition of that. Make sure when you're using that measure distance tool, you choose the planar. You need to choose planar if you're using a planar coordinate system like a state plane. And so, yeah, this is just some notes about how to look at this. And if anyone has questions about this kind of thing, if you're using different coordinate systems, you will want to be aware of that. And these are key takeaways. And how am I doing?
Hey, you're done. But
Oh. All right, that's my last slide. Okay.
you can see the rest of this presentation in October. Thank you, Trish.
Yeah, contact me if you have any questions about that. Thank you.
Terrific. Thank you.
Yeah.
Thank you. I appreciate that very much. All right, next up, we have Michelle Stewart from Rutgers University examining the NJ Restore mapping application. But I'm going to ask you to hang on for just a second. We're going to get on here to switch you up, and I won't start your time until you step up.
Yeah. Just left, right.
Hi, everybody. I'm Michelle Stewart from Rutgers University, and I'm here to talk to you about the NJ Restores suite of web tools that I built using some application development. Okay, so what is NJ Restores and why is it spelled that way? Thanks. So the NJ Restores is actually an acronym. Every time I submitted these web pages to be made public, they would say, I think there's a typo. But NJ Restores stands for the New Jersey Restoration Tool Organization Suite. And it's a suite of tools that focuses on 3 steps for wetland restoration: finding where to work, what are the issues, and how to do restoration work. And basically, what I was able to do was take the work that GIS professionals did and make web application tools that help. It's a suite of tools that work together to help people find wetland restoration work. So sites were nominated using ArcGIS's Survey 123, and then that static data set, the survey was closed, and that static data set is used to publish this layer that then describes areas and projects where wetland restoration work is either undergoing or is needed in the state. I made my web app using React and the ArcGIS JS, they changed the name, Maps SDK for JavaScript. But a similar application could be created in Experience Builder. And the reason we didn't use Experience Builder is that all of these tools work together. And so we needed to be able to read information from the incoming URL and apply that in the application. So from the CRAP website, that feeds information into the Restoration Explorer website, which allows a closer look at the issues facing the location. So we have a host of layers that are feeding into this web app, but basically it lets people really drill down into specific location it's facing and get all of the pertinent information that they would need to begin wetland restoration work. And again, I built this with React, and a similar application could be used with Experience Builder. That feeds into an application called Watch, which originally was a partnership for Delaware Estuary Excel spreadsheet that we turned into a React web application. And that allows scientists to go out into the field and put in real-time data that marsh is facing. So there's a ton of data that goes into this. There's vertical position, hydrology, biology stuff. There's a ton of information. And then the user gets a report out of that. And that information can be used for the next website, which is the feasibility model, which again, what used to be an Excel spreadsheet with Partnership for Delaware Estuary, but is now a web app. And that lets people know there's a lot, this is the simple image, but it's a lot of information goes into like what kind of factors are going into the project. And then this puts out a feasibility estimate of like, how feasible is this project? What parameters could be tweaked in order to make the project more successful? And then another restoration, like kind of a different branch of that restoration outlook, is going back to Restoration Explorer. There's a living shorelines tool, and that tool, again, clicking on an area, these are, I think, like 10-meter pixels. It's very, very, very zoomed in. It will tell you for that specific location what are feasible approaches to wetland restoration, what sort of issues is that tiny little piece of New Jersey facing, and what are the best ways to overcome it. So all of these applications I built using the React and ArcGIS SDK. And really what I'm interested in is if anybody has any questions for me or wants to talk to me, to reach out. So I would love to talk to other people who are building web applications. I would love to hear from you. But also if you have questions for me, if you want to reach your community, get your data out there, I would love to talk to you and help you with that. Yeah.
Thank you very much, Michelle. All right, so next up we have our own OGIS Scott Costello, and he's going to make sense out of various imagery formats and options offered by NJOGIS. Yeah. Yes. And it's really like centers.
Okay, so my name is Scott Costello. I'm the manager of the New Jersey office of GIS. I want to talk a little bit about the imagery options that we provide to everyone. There's a lot of variety and different formats and data sets. So just give you a quick overview of them all. So a little bit about the technology. So right at the top is the website. Go to the engine website, go to enterprise data and imagery. All the stuff's in there. But the two main categories of data are downloads and streaming data. So the downloads are pretty self-explanatory. It's such a big amount of data that we do that through Amazon Web Services, and there's directions on there how to go in, grab the data, and pull it out. It's all console-based, but the instructions are very clear, and it's pretty simple to use. Streaming data. This is the one that folks use and like to pull into ArcPro and all kinds of other stuff. So those come in different flavors as well. So we have WMS, Web Mapping Service. The OGC standard was created back in 1999, and it was updated to the current version of 1.3 back in 2006 and hasn't changed since. So that is kind of a static technology, and it's one of those things that it just works. The way we serve it out is through an Extensys server, which is the former LizardTech technology. And that technology platform is also stagnant. It's not moving forward. The company that bought LizardTech is just letting it ride into the sunset. But the way it works is the WMS takes the request from the client, and depending on the scale and your projection, it will automatically, on the fly, recreate the image and send it back to the client. And this all happens, the amount of work that it does to provide the image back in a couple of seconds is pretty amazing. But there's the catch. It's a couple of seconds. So then we have cache imagery, which is where we do all that rendering ahead of time, and we put it together and serve that out. And then when the client call comes in, it just goes to the cache, grabs it, boom. There's no reprojecting, reprocessing, or anything on the fly. So there's some trade-offs there in that every cache you build is like the giant pyramid layer of all the different scales for a data set at a given projection. If you want to do a different projection, you got to build a whole new pyramid. And that takes up a lot of space. So that's kind of the trade-off. But the services that use the cache imagery, there's an ArcGIS REST cache map tile map service, easy to say, and the web tiled map service, WMTS, which is kind of like the new version of the old WMS, the OGC format, OGC standard. So, and just comparison, the cache stuff is really fast. The WMS is a little more versatile, and your highest quality is going to be from your downloads. So all the different image categories that we have of the image data sets, I kind of group them into three categories. So here's the vintage stuff going from 1920 to the 80s. And a lot of them are only for coastal areas because it was a special project with DEP or something like that. But we serve all these out as a WMS, and most of them you can download. The 80s one is available on the USGS site, and there's information on the engine site how to get there. Now, there's NAPE imagery. So this is current imagery, but this is funded by the U.S. Department of Agriculture. So it's all leaf on. So if you're trying to extract road lines or building footprints, this isn't the data for you. But if you're trying to do analysis of crop growth and things like that, this is the data for you. And these are all the different data sets we have. Since these are being served out by USDA on REST sites now, we're not producing any more WMS services. So it's self-service for folks if they need DAPE imagery in the future. Now, the New Jersey funded imagery. This is the leaf-on imagery, but it has the highest positional accuracy because we spend a lot of money to make sure that the vendors do the flights exactly how we want them to the horizontal specifications that we want, which is very tight. And this is the data set that is the base for all the data that we build in New Jersey. These are all statewide, 4-band imagery, resolutions about a foot. And they're all provided as a WMS, but here we also see that we serve these out as cached imagery. But we're only doing the RGB, the natural color, and in Web Mercator, there's one with state plane there. So statistics drive services. So here's a chart of all the WMS services that Office of GIS runs. That big blue bar at the top, there's actually little blue bars for all the other things in there, but the big one at the top is the 2020 statewide imagery. 7.4 million hits in last May. In comparison, the cache 2020 imagery was 100,000. So it's getting a lot of use. So here's the key. This is a video of them both going to a preset Zoom, which is the baseball stadium next door. And we'll play that. Boom. WMTS is there, and you wait for the WMS. You wait for the WMS, and there it is. So it's about 100th of a second versus 6.5 seconds. Now that was, I cleaned the cache and everything like that, so it was the worst case scenario. It's usually about 3 seconds. So the image service you need depends on what you're doing. You need high detail, download the raw tiles. If you need detail at different scales and projections, and you have a little time, do the WMS. If you need fast imagery, Web Mercator, it's WMTS all the way. So
That was light.
And please read the metadata. All the details are in there in far more detail than I just used. Thank you.
Scott, thank you very much. All right, I'm gonna just announce. I'll let you do this if that's okay. Okay, next up we have Andrew Garcia from the NJDEP talking about watershed restoration. Thank you.
Yep.
Hello, I'm Andrew Garcia from the New Jersey Department of Environmental Protection. I'll talk to you about the watershed restoration application that we created. And so what is watershed restoration, right? So I'll just read this off here. Watershed restoration refers to the process of restoring impaired and threatened waters by reducing pollutants in the watershed, therefore improving the health and functionality of the watershed. So watershed restoration aims to address various environmental issues such as water pollution, habitat degradation, erosion, and loss of biodiversity. So these two examples here are of community rain gardens in Patterson. So we'll map out some of these different projects that are in the state, and the application shows you what that looks like here. So the main layers that are in the application that are created are the watershed restoration projects and the watershed based plans, which is a polygon layer. These show the various locations of any kind of projects, not just rain gardens, but any kind of restoration things going on in the state. And we're updating this as more information becomes available. This application was created using Experience Builder, updating from the Web App Builder one that we had previously. So some of the helpful tools that are part of the app, let's go over some of them here. The parcel search widget is one we're pretty proud of. It allows you to obviously search parcels in New Jersey by block and lot, and the municipalities are all preloaded in there. So the query goes a lot quicker, and you'll see this little GIF here. It does zoom in to your area pretty quickly, and it's a lot faster than loading all of the millions of parcels in the state all at once. The other one here is the pop-up window. It'll show up if you click on a feature, and it will show a little URL for the project itself, as well as a image of the project there in the pop-up. So perhaps you're looking for a site that has NGEMs. It's like near an NGEM site or something, and you have a program interest ID, and you could use that to search similarly to the parcel search. It'll also zoom into that site if you know where it is. The set filter feature can zoom in if you're looking for things like different kinds of projects, different restoration projects, what town it's in, or you could sort by year or something. So all that information is all out there in the attribute table. One added benefit now of using Experience Builder is setting up layers of mutual exclusion. So if you have the watershed restoration layers but are broken down by either single symbol or categorized symbols. And because of the mutual exclusion, we won't have the same layer overlapping. And you could see that there's a lot more like different kind of layers than I have shapes. So I group them all together where we have like the ecosystem restoration, other restoration ones, they're all triangles. So we kind of just color them differently. And similar shapes like the nutrient management is a pentagon and agriculture practice is a hexagon. So they're kind of similar to look at, but we made them different colors so that you can distinguish them a little easier. And I think it's a lot better now. Also, it's a lot easier to group things together using Experience Builder. In Web App Builder, it was pretty difficult to get them all like that. So now you can turn them all on and off once all together. So the next steps here for this project, we're going to create a hub using story maps. It will show an interactive map, which I just showed. And it'll also show a map breaking down the watershed regions in the state and filtering all of them out. So that's to come. A map will also show some of the success stories, projects we want to highlight and talk about that we're very proud of, and their website for more information. So this hub will come out soon. Right now, it's just the interactive map, which is public, but all this information will be available for people to look at and see some of the projects that are going on here. So thank you. If you have any questions, feel free to email me, talk about the app, talk about any of the widgets I created. Appreciate the Geospatial Forum allowing me to talk here. Thanks.
All right, thank you very much. And in under time too, that's great. Okay, next up we have Carl Villacova. I hope I said that correctly. From the Mid-Atlantic Ocean Data Portal at Monmouth University. First, we're gonna let Ankit step up to here and shuffle your presentation.
Thank you. First off, happy National Ocean Month, and that makes it a pretty appropriate time for me to come here and tell you a little about the Mid-Atlantic Ocean Data Portal. My name is Carl Villacova, the Communications Director for Monmouth University's Urban Coast Institute, and the project manager for the portal. So to put the portal in perspective, a lot of people, you go to the beach, you look out at the water at this vast void and think, wow, what a calming view that is. Nothing to see, nothing going on out there. But the reality is much different. The ocean is a very busy place, and especially here in the Mid-Atlantic, it's getting busier all the time. You've got some of the busiest ports in the world in New York, Norfolk, Philadelphia. You've got a thriving commercial fishing industry. You've got lots of recreational boating. For the first time ever, you're going to have freestanding structures in the middle of the ocean with offshore wind. And what the portal does is show how all of these things relate to each other, and in some cases conflict with one another, so people in ocean management roles can make better informed decisions. The portal is free and publicly accessible at portal.midatlanticocean.org. And what's on it? Currently about 6,000 different map layers organized in a dozen categories, all long-range data focused on ocean areas and anything from marine life habitat to vessel traffic patterns, offshore wind plans, recreation, you name it. Pretty much anything going on in the ocean in our region, you can find out about it. Our tech team is currently Monmouth University, where I sit, Rutgers CRISA, Duke University, our developer EcoTrust out of Portland, and we work under the guidance of MARCO, the Mid-Atlantic Regional Council on the Ocean, which is a consortium of state governments from New York down through Virginia to work on ocean issues. A few examples of how it's being used. Certainly, offshore wind has been a major driver of what we've been adding to it, helping those in government roles, for example, figure out where wind can and can't go if you don't want to have it be in the way of shipping lanes, of really important commercial fishing grounds, etc. People think that submarine cables going, across the Atlantic are a thing of the past in this wireless world, but they're actually very important and still carry about 98% of overseas traffic. And you're seeing the portal used to help design the alignments a lot of the new cables that are being used for fiber optic internet carrying by firms like Google, Microsoft, Facebook. So, the portal can help figure out, in this case, looking at Virginia Beach area, how to get them out of the way of where unexploded bombs from World War II are deposited, where bottom tending fishing gear runs, other hazards to it. Guard has been a big user. An example, they used it recently to design these kind of freeways. They're at sea that no offshore wind turbines will go, and a series of anchorages, thinking in light of climate change, in light of changes to the ports, what will the traffic patterns need to accommodate in the future? It is also, we didn't foresee this, but it's being used a lot for educational purposes in classrooms from middle school to high school. Scott has been a very great user of it when he was teaching at Monmouth. And we've been really happy about that. And it's really kind of upped our game to keep it very simple in the terminology we use and its functionality. And we're very happy to see that and want to continue to nurture that. I'll stop there. There's my email address if anybody would ever like a more formal demo and like to learn more. So thank you.
Very good. Very good stuff. All right. Next up, we have Jacqueline Ganter from the Rowan undergraduate program. Jacqueline, terrific. We're estimating changing the marshland habitat and conversion potential for diamondback terrapins. Ooh, all right. Terrific. Thank you. I'll start as soon as you get up. Just a little bit. Cool.
Hi, so I'm Jacqueline, and I'm actually former student from Rowan. I just graduated, but I'm here to talk about some of the research I did on projecting and modeling diamondback terrapin habitat with different sea level rise scenarios and how development pressures may overlap with that. So diamondback terrapin, you've probably seen if you've been at the beach. It's a brackish water species of turtle that resides in the saline marshes of the New Jersey coast. And they're species of special concern in the state because of a variety of reasons, but what I looked at specifically was habitat loss from both development and inundation with sea level rise of the marshes. So a bit about New Jersey's marsh habitats. They're very variable, and they're especially susceptible to sea level rise because of our sinking land from ice sheet retreat. So compared to 7.6 inches of sea level rise seen since 1911 on average globally, we've seen 17.6 inches of sea level rise. And so I used the New Jersey DEP's likely scenarios for sea level rise, which is 17 to 83% likelihood. I looked at 2050 and 2100, which looks at 0.9 to 2.1 feet of sea level and 2 to 5.1 feet of sea level. So those are the 4 different scenarios I looked at for my projections. Marshes respond to sea level rise in a few different ways. They can accrete vertically, so sediment will deposit on top of itself, and as sea level rises, marshes can keep up with it. If they can't keep up with it, then they will become inundated and habitat will be lost. They can also migrate into open land, so as sea level pushes inland, it can go into open spaces like agricultural land and parks and become new marshes. So basically, I modeled where might diamondback terrapin habitat be in the future under these scenarios, how much will be lost, and I looked by municipality, which municipalities have the greatest potential based on their current conservation practices to conserve land in the future. So I looked with land use land cover data from 2015. 2020 land use land cover data just came out. I just missed it when I did the research, but I used that. remotely sensed imagery from Landsat 8 for July 4th, 2022, as well as a digital elevation model. So I use thresholds to create sea level rise layers. And I also use projected land from a variety of sources like open spaces from the NJDEP and the US Gap Analysis Project. And I essentially masked current marshes from land use land cover data with both sea level rise layers and also a combination of a normalized difference, vegetation index, moisture index, and water index that I use to essentially make a layer of land not suitable for marshes, so I could update the 2015 layers for 2022. And I merged it with accretion and migration layers that I got from the New Jersey DEP that was developed by Duke University. And so I combined that with the sea level rise layers and also a combination of protected land now to determine how much marsh will be lost, where will marshes be in the future, and how much of that is under current conservation. So these are the numerical results you can kind of look at. The biggest result is that 99.4% of original habitat is projected to be lost under the most severe scenario by 2100. And that's the same. There's losses for protected habitat, nesting area, which is beaches. For this purposes of the 6-minute presentation, I want to just focus on habitat. But severe losses throughout the state. This is current habitat, of which I created a map for. These are broken down by a few municipalities, so more zoomed in. You can see where habitat's being lost. Gained is in green, and remaining habitats in blue. But the most important maps I think I made for this are these couple. So this series of maps shows under each scenario which municipalities are looking at gaining habitat through marsh migration, which are all in green. And you can see that this is kind of concentrated around Philadelphia and closer to the Delaware River. And over time, with more sea level rise, more marshes being lost along the East Coast. In contrast, this series of maps shows under each scenario how much habitat is being is under conservation by percentage. So the areas where a lot of habitat is growing, so by Philadelphia, a lot of that habitat is not being conserved right now. And a lot of the areas where habitat is being lost currently has a lot of conservation potential. So there's a big conflict where where future habitat will be is not properly being conserved right now. And once that habitat forms, a lot of the terrapins will be susceptible to development pressures. So if we could use these maps to determine which municipalities need to focus on conserving their open spaces like parks, like agricultural land, where marshes might form, we can better plan for terrapin conservation in the future with sea level rise. Yes. So thank you to everybody who helped me, especially Dr. Crispin back there, one of the coolest professors of the GIS department at Rowan, who advised me. And yeah, so thank you. No, you're good.
Thank you very much.
Thank you.
Fortunately, the alarm sounded right at the last second there. Sorry about that. I would have stopped that. Okay. Thank you again, Jacqueline. Next up, Jacob Jordan from New Jersey DOT, doing a comparative study of jug handles and signalized intersections. And there's somebody at the front door. Jacob?
Hello, New Jersey Geospatial Forum. I'm Jacob Jordan, undergraduate student at Rice University. Unfortunately, I must have miscommunicated something because I do not work for the NJDOT, at least not yet. But I must have been feeling a bit homesick going to school in Texas because I spent a few weeks on this project about jug handles. Now, I'm sure that everyone here has their opinions on jug handles, pretty ubiquitous part of driving in New Jersey. And at first, I was confident that I knew what a jug handle was. And here's an image of what I would say is a clear jug handle. You see how the left turns are directed away from the intersection and handled by these loops. But while doing this project, I discovered that basically anywhere where the left handles are directed away from the intersection, can be considered a jug handle, whether that's in a slip lane or whether it's in a full like partial cloverleaf setup like this. Basically, the goal is to remove the left turns from the intersection itself. And so jug handles are often also signalized. So you can ask why I separated jug handle and signalized intersections. Well, basically, I was separating intersections where left turns are handled by a jug handle and where left turns are handled by the signal. So I wanted to figure out which type of intersection was safer. And to do this, I looked at NJDOT's public available crash data. For every US and state route in the state, you can find a table just like this on the NJDOT website. And so using ArcGIS, I split routes into segments using this data and looked at the crash rate along each segment. I split segments that contained only jug handles. I marked as jug handle segments, and segments that contained only signalized intersections, I marked as signalized intersections. And so you can see that a little bit visually in this, for example, on New Jersey Route 36, how I made these differentiations. So not every single intersection could be included because some of these segments are very long, contain multiple types of intersections, but a good amount were. And so I selected 8 highways that are across both North and South Jersey to look at the difference across the state. And so I covered most counties in New Jersey through this process. However, what actually surprised me is that, and at first I was a little bit disheartened, is that there was no definitive result. And at first I was disheartened because I felt like I couldn't say anything with this, but I realized that in reality, what this shows is that there's not convincing evidence that jug handles are safer. Like the conventional wisdom from the Department of Transportation is that jug handles are safer intersections because they reduce the amount of crash points in the intersection. However, when we look at the crash rate, we can see that there's not convincing evidence for that. And so while there may be other reasons to implement a jug handle, like reducing travel time, reducing congestion, being able to go for shorter timing durations on the light, I think that I would argue that safety is not one of them. This presentation was pretty short, but thank you for your time.
Thank you for that lively topic on very dry subject. So that's you did wonderfully. Thank you for that. All right. So next up we have Owen Sellis, New Jersey Highlands Council, classifying, extracting impervious surfaces across the highlands.
Let's press the arrows, right? Yeah. Yeah. Hi, everyone. I'm Owen. I'm a GIS specialist at the New Jersey Highlands Council, and I'm here to briefly share about an open source Python code base our agency developed to extract 5 years of impervious surface data using AWS and Engine's cloud optimized leaf-off aerials of New Jersey from 2002 to 2020. The Highlands. Yep. I'm just gonna make it a full view. Sorry. Oh, gotcha.
I'm not the tech.
Thank you.
Thanks.
The Highlands is an interstate region designated by the Federal Highlands Conservation Act of 2004. And the New Jersey Highlands Council is a regional planning and science state authority created by the 2004 Highlands Act to protect the region's critical water resources, as well as environmental resources, agricultural land, and scenic landscapes. Impervious surface is any structure, surface, or improvement that reduces or prevents stormwater absorption of stormwater into land. It can impact water quality because it increases surface runoff, which picks up and carries pollutants into water bodies and increases peak flows and the scale of flooding events. It is also relatively easy to measure geospatially using remotely sensed data and link to water quality. The Highlands Council uses impervious surface data for a number of different purposes. We use impervious surface to designate areas within the region as existing community zone, which is one of the 5 land use capability zones in the regional master plan. We also use impervious surface data to indicate and track changing water quality in the 6-year RMP monitoring program recommendation report for subwatersheds, which is what you're seeing on the left there, where impervious surface is increasing by a subwatershed or decreasing. There are available data sets for impervious surface for New Jersey. The DEP actually provides data as an aggregated, visually inspected percentage of land use land cover patches for several years. Although we noticed some anomalies in the 2015 data that made it not useful for a time series that we were trying to do. The DEP also provides a spatially explicit, so it actually maps impervious surface on the ground at a 1-foot resolution snapshot of 2015 data that uses a mix of supervised classification and also some manual digitizing for building footprints and other features. We wanted to extract, also the USGS provides a 30-meter resolution data set as a percent of grid cells. We wanted to extract high-resolution, spatially explicit impervious surface data from every DEP multispectral cloud-optimized geotiff hosted by InGen to have the latest 2020 data, which wasn't available until more recently, and analyze changes over time since 2002 with a consistent methodology. Our model uses 12 trained images for each year. They're 5 years, and semantic segmentation provided by raster vision, which is a Python framework for machine learning for imagery, to extract and export impervious surfaces all in the cloud using Amazon Web Services, which makes this large amount of data processing quite quick and very efficient. This is a non-Esri approach. It's open source, so anybody can use it. It does not require the expensive Esri licensing. Is flexible and can be retrained on any feature of interest. It can also be used for object detection, and it can be run anywhere that is covered by the DEP's the imagery hosted by InGen. The Python codebase with documentation on how to run it on your own is available on GitHub. We'll make that public very soon. There's just some disclaimers that we have to add before making it public. So the results, I regret this slide because the time series does not account for the error for each year. There's an 80% accuracy rate using the F-score, which is a common metric in machine learning to assess the accuracy of predictions. I didn't account for that in this chart, but still this slide shows some of the things and trends that we get to explore now using this data set. And we can continue to improve the accuracy with further training and analysis. The 2020 data set of impervious surface for the Highlands region is available for download on our open data site, which is linked here. And that's the end of my presentation. Happy to take any questions by email or after this meeting. Thank you.
Presentation. That was fantastic. Thank you. Our next up, we have Joseph Smalley, a fellow county contingent from Middlesex County, tree tracking field maps and parks of Middlesex County. Joe?
Hi, thanks everybody for being here. And to the people who are remote, thanks for being there. Just wanted to give a quick shout out to the organizers of the event, the New Jersey Geospatial Forum Executive Committee and the Office of Information Technology. I know it's a lot of work. So today I'm going to be talking about a mobile solution that we created in Middlesex County using Esri field maps that helps users in our Office of Parks and Recreation keep track of all the trees that they need to cut down. This is not revolutionary technology. Many of you in this crowd I know are probably doing similar things, many of which are probably far more technologically advanced than what we're doing. Additionally, after I put the finishing touches on this, I noticed that Esri released a complete out-of-the-box ArcGIS solution for tree management. which does everything I'm about to show you better. Yeah, always one step behind us, Edrius. So this project was successful because of three important factors. The first was the launch of our Enterprise GIS portal. We have a three-tier, highly available, cloud-based deployment of ArcGIS Server and Portal for ArcGIS with associated geodatabases. With Enterprise, there's an integration of sharing and security between server and portal. So this has allowed us to simplify our authentication process. Okay, so we also have unlimited viewer accounts, and we're now using Active Directory authentication for our logins. So this is a method of logging in that our county employees are already familiar with because they do it all the time. Previously, we had to ask people to remember a separate ArcGIS Align account, and they rarely remember their password. Plus, there were some other complications. Needless to say, it caused a lot of frustration. The second factor has been the widespread dissemination of county phones, and this has been facilitated by our IT director, Silvio Castelluccio. No longer do we have to wait for the purchase of special equipment as a prerequisite for developing a solution like this. The third important factor has been a culture of collaboration and leadership. We're lucky enough to work with willing collaborators under leadership who that knows what GIS is and also understands the value of it. And this has been really something that our GIS supervisor, Amy Freed, has really contributed to. In addition to a group of GIS specialists that I work with who are never shy of turning away more work, especially when it's able to benefit various departments in the county. So 2 years ago, two guys, Kyle Melkovitz and Bob Cedar from the Parks Department, approached me. They had heard about GIS through the grapevine, and they wanted to get in on the action. These are the guys who carry around chainsaws all day. We began to brainstorm ways that GIS can be used to help them with their job. I don't want to go into too much here because this is just kind of like a simple field map that they're using. Shows the map, gives them an option to add a point for every tree that they cut, and allows them to answer various questions that they're interested in. Many of the answers to these questions feed various widgets and statistics in our dashboard. This is the dashboard. It shows a map, a filtering pane on the side, a attribute pop-up, and a totals indicator. Mostly we've cut down almost 2,000 trees in the past 2 years. Most of these have been ash trees, as you can see from this graph. We're really struggling with the ash borer. As this animation runs, I just want to stress that Kyle and Bob were never shy about approaching me with some of their ideas for how to improve these maps. They would give me feedback on symbology, color, attribute rules, and different functionality of the widgets, and I couldn't have done it without them. Okay, so this idea was so popular with Kyle and Bob's bosses and the other management in the county that they wanted to. It spawned more ideas. They wanted me to create a park boundary app. This is used by many of their county park employees to see where the boundaries are of the park, important for figuring out who's responsible for different problems. We also created this tree planting app. So with this presentation, I wanted to say that, this was this really couldn't have happened without those three important factors. Kyle and Bob and the other guy I work with, Eric Gehring in the Parks Department, are guys who spend most of their days outdoors carrying around heavy machinery while I'm sitting in my air conditioning. So the last thing I want to be doing is pushing buggy and clumsy technological solutions on them, right? But now with some of the investments that the county has made in IT, and because of Esri's great technology, along with willing collaboration and leadership, they're actually asking us for these types of solutions now, and we're actually able to deliver them. Okay, thank you.
All right. Next, we have Derek.
Me?
I'm very much looking forward to this. So mapping in a different kind of media, not digital or paper. Derek Bidar from the NJOGIS is going to talk about landform sculpture, Cradle Mountain in Tasmania.
Hey. Thank you very much. I'm Derek Bidar. I work over in that building in OGIS. So this is the most high-tech thing in my whole presentation. I used Bing Image Creator and gave it a prompt on some sort of futuristic sculpting. I put some words in there and it made this. So. And that's my presentation. All right, let's go to next. All right, so this is Cradle Mountain in Tasmania, Australia. I went here with my wife on our honeymoon. One of the places we went to Australia, and it was wonderful. It's this. You'll see other pictures, just like this, all by itself in this more flat landscape. It's these like geologic formation. It's really, really cool. We took a hike up there, stayed at the lodge, went up to the summit, which is it's somewhere up there, the summit. And it's really rugged. And so you can see this, it's rugged up there. It had like a nice boardwalk and a lake and stuff below. Lots of cool stuff. So, but it is rugged. Here's my wife doing some extreme climbing. But actually it's just challenging climbing. But you can see there that it's got it's challenging. I mean, look, you can see there that you can see the clouds are now level and the earth is level. So this is actually what it looked like. There are these little markers on the side there. You have to scramble up rocks. But this is when you get to the top part. Down below, it's boardwalk. It's real easy. But I did make it to the summit. Great views. You're way up there. You can see all around. Had to climb like a 20-foot wall to get up there. It was a lot of fun. These are, sorry, the resolution of the pictures. Times have changed. Wish I had a digital camera then I went there. I took like 5 rolls of film, and that was like a lot. But they're cute little echidnas running around. Just see, this guy was fast. It's like monotreme to the extreme. They are, and if you didn't know, they're egg-laying mammals. But the real reason I'm here is to just show you my honeymoon photos. So for the next 5 minutes, if you'll bear with me, we'll do that. Or not. This is the inspiration for what I did. You go to the parks and you see those things where they have a diorama, a 3-dimensional thing. It's kind of hard to see because of the photo quality, but up there you see the brown ridge there. They have some incredible vertical exaggeration going on here, but this is what kind of served as the inspiration. So I was like, how can I make something like this? But I'm not going to make it big. I want to make something small. So I had to do my research. It's hard to find pictures. Well, you can find pictures, but it's hard to remember back to what I saw there. I'm thinking about it like I want to see the bigger area. I can see the mountains there. I can see kind of like the vegetation, but like what's going on there. I had to find some more. Look at other places. This shows the kind of vegetation in the foreground. I can see how it rises out of there. I can see what the lake looks like from some other vantage points, but they're just pictures. They're static pictures. I wanted something I can more explore. So head over to Google Maps. You can see the scene here. Cradle Mountains in the beginning there. You can see them in the middle there. You can see the summit, but it doesn't look like it did in the other picture. It's just we're looking down at an aerial here. But I can get a layout of everything that's there. It's kind of cool. But one thing Google has and other places have, but I use Google Maps, is you can tilt it, and they have some elevation data there. So I can kind of see where the mountain rises up there in the middle. It's for like a spine, how it looks, what the trails are, what the exaggeration is, or what the elevation changes are there. So I'm looking around and thinking, okay, well, I remember heading in, zooming in on the summit here. It looks nothing how I remember seeing it. This is a 3D elevation model, crude kind of, with a aerial draped on top of it. It doesn't have, I can't see the sides of things. I can't see what it looks like. This is what I remember. It's very different. So if I had just gone on the aerial and tried to remember back 20 years and what's happening here, wouldn't have worked. So I had my source material, so kind of get started on working. I used Sculpey modeling clay, and you can see it just fits in my hand. So I started with a really basic, all one color, rough landforms, did some kind of crude measurements and did vertical exaggeration. I wasn't measuring the thing. I was more measuring and just kind of getting relative measurements, and basically pressed my thumbs a bunch into some clay and baked that thing. So I had a nice stable base and that wouldn't change. And then I started adding things to it. You can see my setup here had different colors. I'm mixing things. I had a magnifying glass there so I could see what I was working on, because I was using toothpicks and stuff. And cool little tools that I got at, I don't know, one of those art supply places. So yeah, I mixed and added the landform colors that I wanted as a base. And then I needed to kind of shape that and make my vegetation and all that. So I started adding little mixes of green and other things to there all the time, kind of going back to my original one. That my initial little puck that I made was okay, but I had done some things wrong as I realized it. And so I had to adjust for that with building up more clay than I thought I would need. And so it started to take shape. I made up those things using lots of little tools, always going back to my map and stuff. And then as we get to the end here is different views of that. And I made a little wombat. Because we did see a wombat. I didn't get a picture of it. They're like little tanks running across the road. Apparently they survive very well because they have this like solid bony back that but they'll also, if you do hit them, they will destroy your car, apparently. But there it is, Cradle Mountain.
Thank you very much. That was awesome.
Someone asked if they're edible. I'm guessing no.
No.
Well, well, I don't know if he's talking about the wombat or your sculpture, but and was no, probably.
Sculpture is not Next up, we have Lisa Jordan from Drew University talking about mapping population visualization and health analysis in New Jersey using the statewide parcel and building footprint data. Thank you.
Hello, good morning, and thank you. I'm Lisa Jordan from Drew University. And thanks to my GIS class this summer who's joining online. I'm hoping you're getting lots of great ideas for your projects. And I hope you're enjoying these presentations as much as I am. So I am a student of Jeremy Menace, who wrote one of the first papers on digital dosimetric mapping when we were at the University of Colorado. He now teaches at Temple, and I'm in Madison, New Jersey. So I want to describe what dosimetric mapping is and its uses by looking at some examples, explore unique layers that contribute to potential high accuracy dosimetric mapping in our state, define dosimetric mapping in some simple like ArcGIS toolbox tools, and visualize the results with some help data. Dosimetric mapping involves converting thematic map representations of population from administrative boundaries to more specific areas where people live or work. A few reasons to consider dosimetric mapping for visualization analysis. For visualization purposes, seeing regions as not fully inhabited, as only by people, could facilitate efforts if you're fans of like the idea of half Earth, where we share our planet with other species. It could be useful. It's also useful for analysis where people are more likely to reside. So within administrative boundaries, if you're looking at people in proximity to environmental hazards, you can get more accurate estimates. There are a number of everyday mapping applications that use dosimetric mapping. So the EPA Enviro Atlas has a 2020 dosimetric map layer you can add. One that I've used for a long time is produced by Oak Ridge National Laboratory, their LandScan data layer. And if you haven't used this before, I encourage you to look up LandScan. They have a global population data set that they update annually. And they also have it for the United States at, I think, 100-meter resolution. They have daytime and nighttime population layers, and you can download them or you can use their web mapping survey. So there's a whole lot now. If some of you are familiar with the Socioeconomic Data Analysis Center at Columbia, they host a bunch of different dosimetric or population grid layers, global and local. WorldPop, LandScan, Esri has a grid of population. So does CDAC, the grid of population of the world data set. So this is basically the idea is you take your population data set that's maybe by census tracts or blocks, and you're like, well, where are people actually living within those blocks or within those tracts? The other data layers like LandScan and WorldPop, they're using land use, land cover data. Those are where people live. They live in the urban areas or maybe not living in areas like water. So using identifying where water, where wetlands are, where forests are, those become the masks for where people aren't located. So you use those masks to then figure out, well, where are people within these areas? So this is an example of just a toolbox where you create the mask from, say, the New Jersey land use land cover layer, and you clip it. Here I clipped it from the parcel layer. And then I attribute the attributes proportionally to parcel clusters. So this is kind of what it looks like. You would have something like census blocks. This is from where I live in Madison, New Jersey, small little borough. And you have the population block groups on the left. And then, okay, well, using parcel data, land use, land cover, building footprint data, where are people within those? This is where they are. So what you see underneath there is then just the aerial image of what's below. But those are unpopulated areas, maybe they're office parks, for example, no one living there, forested area or a conserved area in the town. So it could be useful to look at with localized health data as well. Some of you are familiar with the wonderful CDC Places data set. I'm a big fan of it. It's almost 30 health metrics that are at the census tract level. So you could estimate using dosimetric mapping where are folks with asthma, where are folks with diabetes. If you're interested in those like proximity to highways and exposure to particulate matter, is that causing Alzheimer's? Those kind of studies can use this sort of data sets for. So what are next steps from this? Well, I think there's a lot of use for dosimetric mapping for various locational analysis. I just did a simple example here with Morris Madison, but you could look at more county or even statewide level. A lot of dosimetric mapping uses tessellations or fishnets to make a grid of it to give you a kind of standardized representation of population. But there are always issues with downscaling population. Do we know its accuracy? There are questions there. I think the initial uses that I've seen it for are in disaster response and preparedness, where you need a very quick estimate who's in the tract of the hurricanes or potential tract of the hurricanes, who was in the zone where the Indian Ocean tsunami came in. And so it's those rapid estimates of population that are used for emergency response and planning where it comes into use. But then there's always questions about are those numbers right? How do we know? How do we check? So those are areas for future research. Thank you for listening.
Where's your screen? Where's this? Oh, I see. Aha. Okay, good. All right, next up, we have Christopher Blackley from Meadowlands Research and Restoration Institute, talking about localized predictive storm surge flood maps for the Meadowlands District. Thank you.
I'm Christopher Blackley. I am from the Meadowlands Research and Restoration Institute, and I'm showing off our storm surge flood prediction maps. So the purpose for these maps is we wanted to give a localized predictive flood visualization for our residents and business to give them tools to help find those flood prone areas and potentially figure out why those areas are flooding. Also, this contributes to the FEMA's community rating system. So we get some flood insurance discounts for our residents. And also this gave us a chance to investigate or understand better our tie gate network that we have in the Meadowlands. Because if you know anything about the Meadowlands, it's a very low-lying area that has the Hackensack River cutting through it. That leads to Newark Bay. So there's a lot of tidal influence from the Newark Bay. On the map on the right is an outline of our district in red, and the blue is areas that are less than 2 feet from the mean high water mark. So you can kind of see how flood prone the Meadowlands is. Most of you are familiar, but I started off with looking into watershed boundaries. USGS has a natural version, and as you go up in the Huck number, it gets smaller in size, and the watersheds kind of fit into each other because they have a shared drainage pattern. But for our district, which is again in red here, it doesn't really work out too well, especially as a local level. You see the ridges on the right and left side that kind of define the Meadowlands, but a lot of the areas just don't give a good sense of what's actually happening and how the water is draining locally. So we used our elevation data and a couple tools from Arc Pro Hydro to kind of build this watershed boundary. We have the flow direction model on the left and the catchment grid on the right, which kind of shows how the water flows through the district. And then this is our localized watershed delineation map, which probably doesn't mean a lot to you because it's a lot of little shapes in here, but being from the region, some of these out and make it understandable how the water moves locally. And here's a couple examples of these delineations. On the left here, you see these two watersheds were delineated pretty precisely. It's a very smooth line, you see, because that's one of the berms in our district called the Cane Berm. I'll get back to that a little bit later. And on the right, I just wanted to show off this very interesting delineation where I thought the map would be delineated by the New Jersey Turnpike here in white, but they actually found this ridge that goes along in this wetland that actually divides into two delineations here, and there's a more shared drainage basin there. So with the watershed delineation, we used like a bathtub model with topology and elevation data to find areas under each elevation. So for the maps, we did from 2 to 8 feet at a 1 foot interval. And we split them up by the watershed boundaries. And then through that, we determined their connectivity to stream networks, which helped us determine, as you see here, there's these green dots, which are the tie gates, what areas are being protected by the tie gates. So in this case, the water is moving up north through here, and the area behind it in red is the area that's protected by these tie gates. But we did have to do some field verifications. So on the left, we're doing a field verification at the tie gate to see what elevation floods that it can protect. We'd also go along the areas around the tie gates to find any flood control points, like on the right here on the Cane Berm. This was our lowest point on that berm, which is around 4 feet. And here's one of the maps. So I split the maps up for each municipality in the district, so there's 14 of them. And each map has its own flood elevation. So for this map, you can see 2 feet. And so for the maps, the red is the areas that are protected by tie gates. The light blue are the areas that are protected to flood. And the dark blue are the water bodies. And also the tie gates show up as these dots along the map. And they have different colors just to give a range of their protective height. So I'm going to flip through these, and so you can just see how the maps change as we go up in elevation. So from 2 to 3, there's not too much change. Some of the areas spread out more, but I want you to focus around these yellow dots over here because they're about 3 to 4 feet in size for the tie gate. So once we go up to 3 to 4, those tie gates start to fail, and you see how the areas start to become more flooded or inundated. And then from 4 to 5, that Cane Berm breaks or would be overtopped, and you see the area behind it is starting to fill up with water. Note though that this is a bathtub model, so these areas aren't going to fill up immediately. It's going to take some time, and high tide also helps this fill it up more completely. And as you see, I go to 6, it gets a little bit more, 7 even more, And then between 7 and 8 is where we saw our high water mark for Sandy. So it gives us kind of a worst case scenario. This is Carlsbad, so it becomes very inundated with flooding. And so those are my maps. You can find them on our website, meadowlandsrri.com, under the real-time water alert level system that we also have. And that's it for my presentation.
Thank you very much. Okay, so next up we have, also from the Meadowlands Research and Restoration Institute, I guess, do you guys call that Mary?
Mary.
It is still Mary, okay.
It's still Mary, but we changed it slightly for the acronym just for fun.
Okay, so Brian Wardowski talking about contamination of the lower Hackensack River.
Great. All right, thank you. I'm Brian from the Meadowlands Research and Restoration Institute. You saw my cameo in Chris's presentation taking GPS points. I will be signing copies later. So we have a suspended sediment trap that we're working on right now. Really, our problem is that there's a need to sample suspended sediment in the estuary. You can do discrete point sampling. DEP has done a very good job of that. They actually took 44 samples for full metals and PCB analysis up and down the river stem. And we have a sediment chemistry database that dates back to the 70s. Anybody that does anything in the Meadowlands, we try to get a copy of it and at least dump it into this database so that we can work with that. So our goal is to assess sediment-bound contaminant transport and then apply all of the information that we have to future data, sea level rise, and see what we can do best to restore or protect areas in the Meadowlands. So just a little bit of background. Sediment-associated metals can represent over 90% of the metal load in the aquatic systems. The sampler that we're going to be talking about was only published in 2000, so this is a very new technology, new in terms of scientific terms. And the whole operating principle is that the water drops in velocity inside the sensor. We'll get there in just a second. The graph on the right, the y-axis is velocity and x-axis is particle size. So the green box is what we're looking at, everything under 30 centimeters per second and under 1 millimeter, really under 4 millimeters, because that's our inlet pipe for the sampler, is what we're looking at, really the fine grained stuff that's very difficult to sample with discrete point sampling. I love this graph, except everything about it is wrong. This is the Niels Bohr diagram of sediment velocity, so don't take this at face value. So what we did is we built a Phillips sampler. There's also a modified version, which is what we did on Elliott et al. In 2017. It is a bidirectional version, so it has a inlet on this side, and on the other side there is a bent pipe, which prevents backflow, so you can actually capture flood and ebb independently. As we said before, the water comes in, drops almost 600 times in velocity, and then the exit is on the other side. We're able to 3D print a lot of our brackets and customize a lot of it. So the stuff that's coming out of this is an excerpt from Phillips et al. You have 0.3 meters per second or 30 centimeters per second velocity. Your output sediment is only 2.1 or 3.6 micron. So you're pulling everything that is very, very fine grained, and you're losing very, very little of that sediment. So you're capturing the majority of what is moving in and out of the marsh. So we've done a few field tests of this. We've had our Argonaut ADV, which is capturing 3D velocity. We've had our SON for turbidity as well. And we were able to put this in and leave this for 1 lunar cycle. Everything that we've been doing is a lunar cycle just to catch normal tide conditions. We would then recover the sample, drain it, siphon off the extra water, freeze dry it. Chemists do that. I don't do that. That's the other building. It's a super secret thing. I don't know what happens in there. So in the flood and ebb, really the Secaucus High School outing, that was our best, that was a full deployment. That was more of our real testing. You can see that in the flood, we see that what was expected is that the sediment is much higher on the flood versus the ebb, but the organic matter is nearly identical. I promise this gets to GIS in a minute. So we have sub-basin delineation. So everything that Chris just went over, we went even further. This takes one of the basins that Chris has from the last presentation and breaks it down into 123 different sub-basins. And even on the bottom left, you can see that we could actually do even more per creek if we really had to. We're able to use drone imagery, LiDAR, and hand digitized creeks for that. So one of the basins that Chris was coming out with is still extremely detailed. This would be like a Huck 20 compared to a Huck 14 or Huck 18. We got all the way down to a very, very small basin so that it's one tidal creek, and you can see the fetch area for that sampler and exactly what's moving in and what's moving out. So from this, we just got a wetlands EPA grant. We got a letter of intent, but we have no money yet, so we'll see how that goes. 6 different sites. We're going to do 2 deployments at each site, a growing season and a fall season. And from this information that we get, this is then going to be applied to our 2100 sea level rise models. And through our statistics and Vulin tools, tides, those packages, we're actually able to calculate the number of inundations, the frequency, how things are going to start working as different tidal regimes change. And we'll be able to predict where contamination should be moving within the estuary, as well as what areas really need to be protected and what areas are, for lack of a better word, lost already. All right, that's it. Thank you.
There's lots of GIS in that. What do you mean? Okay, next up, it'll go. Okay, thank you. I was hoping to talk with you beforehand to make sure I pronounce it correctly. Itiko Peckman from Meadowlands Research and Restoration Institute, Marsh Edge Morphology Assessment using high resolution drone imagery. I'm going to ask you to say your name again to the folks in Zoom. Sure, thank you. I'm just adjusting.
Thank you. Hi, everyone. Thank you for being here and bearing with us. Surprisingly, it's going to be again about the Meadowlands. And my name is Ildiko Pachman. I'm a senior environmental scientist there. And under another EPA funded grant, we set out and to see if we could determine how well our marshes are keeping up with sea level rise and what is going to be the future of the Meadowlands and the lower Hackensack River estuary. Chris already showed this map. The only difference is that mine is red, showing all the areas that are within 2 feet of the mean-high border, which is 2.5 in the estuary. It's a urban estuary. Low-lying residential, commercial, and industrial areas are interspersed with wetlands, marsh areas, and is very prone to flooding. And with the impending sea level rise predictions, it's going to be the flooding risk. The flood risk is going to get even higher. So, as part of the EPA grant, we tried to figure out if using our DJI Phantom 4 Pro drone, which is equipped with our RTK unit, if we could map erosion, like with using high resolution DEM derived from the drone imagery, we could actually map eroding and building marsh surfaces in the estuary. The whole idea is based on the literature that says the left-hand side of the image, the slide, that areas that are marsh areas, marsh surfaces that are building, they tend to exhibit a convex surface model. Areas that are eroding tend to exhibit a concave surface curvature, and marsh areas like mud flats and creek banks that are in equilibrium has equally concave and convex surfaces. So with our drone capable of producing a 2-inch spatial resolution DEM, we set out to find extended mudflat areas in our restoration projects and see if using the DEM we would be able to assess their status in terms of erosion. Altogether, we try to look at 10 different areas, selecting equally on along the main stem of the river and the tributary to see if there's any difference. So the first approach was, since we're talking about curvature and surface graphs, so We digitized the center line of the creek, laid cross sections perpendicular on the center lines, and transformed them into point features at 0.25 feet this intervals, and extracted the elevation values of each point. And these are the curves that we actually imported the value into Excel, the data into Excel, and these are the curves that we got. So at the very beginning, it looked all nice and beautiful. It looked like that we would be able to differentiate between the convex, which is the first set of graphs, and the concave or eroding surfaces, that is the bottom graph. But when we actually tried to do the took all the curves that described one certain marsh area and tried to run a statistical analysis, it turned out that they were not different from each other. We couldn't find a significant difference. All marsh areas had convex, concave, and mixtures of surfaces, so we couldn't really make a difference. So we figured that we have Esri licenses, advanced licenses, so why not try and see if Esri has a tool that we could use for the same purpose. So finally, we ended up settling down with ArcGIS Pro surface analysis tools and run a pixel-based curvature analysis. 2-inch pixel size is not a good resolution for this because it's just all messy and you can't see anything, like I can't see any trend. So thanks to Chris Blackley, we actually resized the imagery into, I think it was a 3-foot by 3-foot pixel size. And this is what we got on the left-hand side. So instead of having to rely on a few cross sections for a 30, 40 acre marsh area, we were able to classify the entire marsh surface into green areas that shows accretion and red areas that are showing erosion. The yellow areas are flat, that are within the error range of the tool. So we deem them flat areas that nothing is happening. After removing the vegetation and the water areas that were still covered by water when the imagery was taken, to remove the error, like the reading error of the sensor, we calculated the areas for all marshes in terms of the convex and concave surfaces, and calculated the ratio index, concave areas over convex areas. And based on our empirical data, our knowledge of the marshes, we set a 1.1 ratio value as a threshold. Above that, everything is eroding. Below that, everything is building, or at least in equilibrium. This is the final result based on the data. Red are the eroding marshes, and green are the building marshes, or that are in equilibrium. Thank you.
Next up, we have Eric Mankey from the Meadowlands Research and Restoration Institute, assessing the capability of indices to detect bioform and low-lying mudflats using remotely captured multispectral imagery.
Possible. Plug this in and pull up a new one. We can try.
Sure.
If you don't. It's.
I mean,
let's take this guy out.
Is that gonna? Okay.
Thank you.
Copy that over, if you would, just so that way we have a copy of it too. If you just close that and copy it and run it from the hard drive rather than the.
Where am I?
Yeah, I need to tell you soon. Okay. That's okay. I just want to make sure we've got because people are going to ask for it. I don't want to give them the old one.
I appreciate it.
No, sure. Okay. We're late.
I'm so sorry.
No, you're okay. I'm just teasing you. All right. Eric Mankin.
Hello, everyone. My name is Eric Mankey. I'm also with the Meadowlands Research and Restoration Institute, and I'm here to talk about our work with spectral indices, particularly assessing the capability of these indices to detect biofilm on particularly low-lying mudflats using our remotely captured multispectral imagery. Now, I know that was a mouthful. Let me get into it and break it down for you. So a little background as to how we got here. Our director had a theory that biofilm presence in wetland mudflats and their concentration can inform conclusions drawn about wetland erosion. Now, in order to test this theory, we first had to quantify the presence of biofilm on these mudflats, and we decided to use our multispectral imagery for this. But first, to be able to quantify the presence of biofilm, we had to establish a process for delineating the biofilm from the surrounding mudflats and water bodies. So when we got out into the field, we flew a DJI Mavic 3M drone at a height of about 300 feet, and this resulted in some very high resolution imagery. Now, this drone we used is typically used for agricultural studies, but we took a particular interest in it because it has both RGB and multispectral cameras. And the multispectral camera actually captures 4 bands, these being the green, red, red edge, and near infrared bands. And we chose this site you see, the Secaucus High School Wetlands Enhancement Site, because we know for a fact that there's biofilm on the mudflats there, and we could visually identify and isolate a certain area, as you see here. So this yellow outline is the study area we isolated. And just visually looking at it, we created smaller polygons where we believe the biofilm coverage could be classified into different categories, these being 0% coverage, 25%, 50%, and 100%. And then we used NV to calculate our indices, and we calculated a fair amount, but only a handful had results we were really looking for. One example, for anyone who's worked with spectral indices, you've probably seen NDVI show up. It's probably the most common spectral indice used in our industry. It's used to evaluate health and density of vegetation. And there's the formula and the value ranges. So this image on the right, the green you're seeing, that is the biofilm. And the red and the lighter colors is more of the bare earth. So the biofilm is being delineated where we expect it to be. However, when we looked at the data in our 4 categories, we could tell something was a little off. So the mean value for the 0%, these values are all for the NDVI, by the way. This trend applied to all the indices we ran. So for how this should work is the mean value should increase for each category. And it does so between the 0% coverage and the 25%. But when it gets to the 50%, it actually goes down, and it goes down even further for the 100%. So there was something wrong in our process. So going back and looking through everything, we found that the Mavic 3M's multispectral camera doesn't actually take all 4 pictures of all 4 bands at the same exact time. There's an offset. It fires, instead of all 4 being taken at once, it fires in a series, 1, 2, 3, 4. So that offset, it's not a big difference in time, but spatially, when we overlay these orthomosaics of each band on top of each other, there's a fairly, not super significant, but like, for example, this area, that's about 4 feet difference between our red band image and the same points on our near infrared image. So to conclude, the indices we tested, particularly GNDVI, NDVI, NDCI, and SAVI, were all good at delineating biofilm where we expected it to do so. However, with the offset between the imagery for each band, that needs to be corrected for both us moving forward and anyone who's doing this kind of work. Yeah, basically to output accurate results, you have to make sure that each band's imagery is georeferenced to each other as accurately as possible. And that is everything. Thank you. Yes, I'm just going to check that real quick.
Leave that one plugged in?
So we can turn off that timer now.
All right. Wow, Sweet 16, huh? All right, so we've got one left. Kate Talbot from Rutgers University. She talked about the watershed planning and wetland function map.
I'd be curious that you turn off the timer. I got 20 minutes.
Sure. The room is yours, Kate.
Hi everyone. I work at Rutgers in CRISA, but this project is a collaboration with the NJDEP in the watershed and land management. And I worked closely with Larry Torak and Kathleen Waltz on this as well. So if you know either of them, we're working on a multi-year kind of broad scope watershed planning project. And the first step that we worked on was filling some gaps. So this, what I'm going to show you is a map that we made to fill a gap that Kathleen in the wetlands program had identified. So the first thing to understand is kind of what is currently available in wetland maps and inventories. So there's a national, the National Wetlands Inventory, and that has a lot of detailed information for vegetation types. And so this is just an example of the types of codes you get, but it's not updated very frequently, and it does require a lot of ground checking. So it's not, it's not easy to really keep up with. In New Jersey, the land use land cover map is kind of our authoritative source for statewide wetland polygons. So that shows you the extent. And then it just has very few attributes. It just gives you this one kind of general attribute that has a little bit about, here the example is more like land use, or it could be more ecological, like showing, the vegetation types. But and then there's also these on the ground approaches, but that has very limited kind of spatial coverage. So what's missing is really tell you what the wetland does. And there's a lot of interest right now in wetland function. So that's the processes that take place within a wetland as part of the kind of self-sustaining properties of the ecosystem. So wetland function, this could be many different things, but kind of three general categories could be flood attenuation, which you could break down into the different ways that floods could be attenuated, water quality improvements, and then providing habitat. So those are types of wetland function. And you can see when you're doing any kind of planning, these are really important to understand for mitigation if there's going to be a wetland lost. When they're going to plan mitigation, well, what functions are we trying to replace? So in New Jersey, we have used this this West Virginia wetland functional assessment method that they came out with in 2021 and an update in 2023. So this was this big kind of data model. And so here on when I was trying to understand it, you can see over on the right, I tried to kind of map it out. So they use all these existing data sets and they pull them together in all of these submetrics. So we actually tried to replicate this as best we could. We have different data sets available to us in New Jersey. So in the end, it was not 62, and we had to replace where we could, but this is generally how our model looks. So we have these three major categories: water quality, flood attenuation, and habitat provision. And they kind of add together to get this one composite score at the end for each wetland of function. So just to kind of show you also for water quality, the way the score is composed is there's these kind of major sub-functions, and then those are composed of these, sub-metrics, and you can see kind of examples of the data sources. So we're trying to pull as much of the relevant data together and kind of boil it down to get these wetland functions. So let me show you what that looks like. So here's an example, and in the scores, this is out of 100, so it gives you just sort of a little snapshot of an area with some scores. And this is a wetland that in that on the ground wetland condition study that I very briefly showed you in the beginning, they had scored this wetland, so they have actual ground data. So we can kind of compare it also to our function map. So at this location, at this wetland, in our map, it got a 15 out of 25 for flood attenuation because it has a headwater stream and wetland peat soil, which are both effective at flood attenuation, but it's also smaller, so it doesn't have as much capability. Got an 18 out of 25 for water quality improvement due to the thick vegetation cover and woody vegetation, which is considered more effective at settling out sediments and improving water quality. And then a 25 out of 50 for habitat integrity because it has some kind of unique and special landscape features, but it's also in this kind of altered matrix. And so our model incorporates the buffer characteristics. So you can break it down, and the overall score isn't necessarily as useful, but you can kind of look at these different examples of the subcategories and get a lot of information depending on your kind of particular usage. And so this map will be in our web tool that actually Michelle, who talked to you earlier, is helping us put together, and there's going to be a lot of information. So look for that coming out in fall 2024. Thank you very much.
So to all the 16 folks that submitted and trekked out here and then presented, and I am truly grateful. I owe you all a beer. And for those, there were a few folks who submitted that we couldn't entertain. And for those folks, I want to remind you that there is the Mid-Atlantic chapter of the Urban Regional Information Systems Association. That would probably be a better fit for some of those folks' talks that didn't make it. And that's mainly because it's more of commercialized than volunteer. Should I go back? Okay. So, hi everybody. Okay, so a couple of things. So now we're going to switch from what should have been the beginning part of the meeting, and that's the open discussion and announcements. The first announcement I have is, again, so 2024 Mid-Atlantic chapter of the Urban Regional Information Systems Association, also known as MAC-URISA. We have next meeting in Friday, October 18th at their event, their biennial, I guess, every 2-year event at Resorts Casino Hotel in Atlantic City. Hopefully we'll see you all there, or, hopefully you'll see me there. See what else we got. I think we had some folks from the state that want to talk to you. Now, before I get to that, is there any constituencies here, county, federal? Oh, okay, so we've got one. Come on up. State your name, your quest, and your favorite color.
I was gonna say how fun it was, the email saying we have 11 speakers, 12, 13, hold on, 14, like within 10 minutes of you. I'm Mark Gaddy. I'm from Delaware Valley Regional Planning Commission, and I represent the regional authorities and MPOs, Metropolitan Planning Organizations, which DVRPC is of one. We didn't have any reports from other members, but I can say that DVRPC's 2023 land use is done. It's on our website for download. And I guess as a service also, it was supposed to be done in 2020. Pandemic delayed that. We did get a 2023 layer done, and then in-house, meaning me, did a 2020 layer. That's done, but it's not up yet. It will be shortly. I just go to dvrpc.org and pull down the tab for data center, and you can find a lot of data there. So that's it for me.
Scott Costello from New Jersey Office of GIS. I'm the state constituency representative. Didn't get comments from other state agencies, but Office of GIS has a couple things. First of which everyone's concerned about, the state contract with ESRI, ESRI. It is very close. We've been saying it's close, but it's very close. It's down to like 1 or 2 items, and the state lawyer folks are reviewing ESRI's latest thing, and we hope to have this closed. We've made, both sides are very aware of trying to get this done so people can get their maintenance up to date before the next fiscal year.
Have any idea how long that contract will be in place for? Is it, will it be the next like blanket that'll go for several years, or is it?
Yeah, I do believe it's following the same structure of 3 years and then options to continue. More contract news, the T-1841 contract for GIS services for state and government agencies has been extended for another year. So it'll go until, I think, June 18th, 2025. So at the same time, that is the last extension of that contract, and we'll be working to get that whole thing renewed in the coming year. And we also have some comments about some service retirement stuff for Maya. So
Right here.
Oh,
yeah, because I'm shorter.
No.
There we go. All right. Hi, everyone. My name is Maya Thomas. I'm a solutions team lead at the New Jersey Office of GIS. I'm also your friendly neighborhood New Jersey Geospatial Forum administrator. So 2 public service announcements. First thing is just, if you haven't signed in today, please sign in. We use your attendance for elections, which happens every year for the New Jersey Geospatial Forum Executive Committee. So I just wanted to put that out there. All right. So service retirements. Hopefully you guys are on the New Jersey Geospatial Forum listserv. We have been sending out a lot of reminders about this, but if you're not, go on the forum website and sign up. There are directions there. We have a ton of retirements. I'm actually really proud of this. A lot of services that we're getting rid of. These are services and applications that are currently hosted on our on-premises ArcGIS servers. We are taking them down, retiring, meaning if you try that URL after Monday, this coming Monday, it will not work. It will 404. This website here, this page, tons of information. A lot of these services are, we are pointing to our partners who are hosting them now, or we actually have them now on ArcGIS Online as a hosted service. So, which makes it a lot more reliable, fast, etc. Good scalability, right, for your web applications that you are hosting. So, again, these services are going away on Monday. I believe that's the 11th. So yeah, if you have any questions, please reach out to us, engine@oit.nj.gov. If you have any concerns, but a lot of this stuff, there's nothing like major, I would say, that's really going away, or there are URLs there for whatever the replacement would be.
So yeah, just an announcement about that. And that's it. Thank you.
We have to clap for Maya. Please step right up. You do have to come up here though. Or I could, unless you want to, no, come on.
Hi, this is Eliza Gross. I'm with the USGS and I'm the National Map Liaison for New Jersey. And I'm gonna take control here real quick. I just wanted to make an announcement that the USGS Data Collaboration Announcement Informational Webinar is coming up. For those of you who don't know what the Data Collaboration Announcement is, if you go to Google and type in USGS DCA, it's the first hit on Google, Bing or whatever I'm using. This is the Data Collaboration Announcement portal. So this is basically funding opportunity, a funding opportunity that we offer for partnerships for acquisition of elevation and hydrography data. This was the former BAA, and now it's called a DCA. So in fiscal year 24, we had our first DCA that has closed. And then on the website, we have all the selected projects. You can open up that. And here's New Jersey's selected project, the 4-county QL1 LiDAR acquisition. So just wanted to let everyone know that we're opening that up again for our next fiscal year. It feels like we just got the projects underway for FY24 and now we're already planning for FY25. But they're having an informational webinar on August 7th from 1 to 2:30 about the DCA. And it just kind of goes over all the proposal materials and everything. And that will be recorded. So if you miss it, you can watch it. So if you're interested in elevation or hydrography data acquisition, finding partners and, getting hydrography or elevation data for your project, just reach out and I can put this link and my email address in the chat. And I also wanted to let you know, the Delaware River Basin Commission reached out to me and they have some funding available for FY25, and they want to collect topobathymetric LiDAR data on the Delaware River, basically from Trenton, New Jersey up through Hancock, New York. So if that's something that your agency is interested in partnering in, reach out to me. And hopefully we could get a big partnership together. I'm reaching out to people in Pennsylvania, New York also. So I'll put my email address in the chat. Thank you.
Thank you, Eliza. Appreciate that. Okay, so any other constituencies? I know we have Nick, he was in the back. Don't forget. I got that, but is there any other constituencies first? Okay, so now we're going to hear from Nick from the Mid-Atlantic chapter of the Urban Regional Information Systems Association. Now, let's see if we can, just since we're talking about it.
Oh, you want to plug our website?
Yeah. Ah.
Perfect. You're going to have to multitask now.
Yes, you actually have to work. Yes.
Hey, everybody. Nick DiPaolo with Macuris on the board. I see some faces here that are also part of the group. All information can be found on this website here that I'm about to go through. And also, we're going to be blasting out an email with some additional information about the conference coming up tomorrow. Before I get there, though, we have our next webinar on June 26th. I think you can see right here. It's a good one. We have, it's going to be focused on indoor GIS mapping, which is kind of a hot topic now. We're going to have some discussions and also a panel discussion there with some subject matter experts. So if you haven't registered, go ahead. It starts at 8:45, I think, till 12, with a lot of good content. So try and check that out if you can. And obviously our upcoming conference and highly anticipated conference that I think you owe some drinks. You probably at the conference.
Yes, I do.
So that's going to be October 16th to the 18th at the Resorts Casino Hotel in Atlantic City. And I've been to other conferences in other states, and regions, and we have a cool venue. There's a lot to do in and outside the conference, so hopefully we'll see a lot of faces there. The abstract deadline has been extended to June 30th. It was actually ended on the 5th, Wednesday, but you'll see that in the email.
Finish your talk, please.
Yeah. And a lot of the presentations we saw here would make great candidates, especially I saw a lot of the Meadowlands crew. Looking at you, if you haven't thought about submitting, or all of you, just think about it. There's some great opportunities to present and share to the rest of the GIS community what you're doing.
The registers are typically like 20 minutes.
There's a couple different varieties. The 20-minute webinar, not webinar, the 20-minute panel presentation is usually the best one. Also, we have sponsorship availability and exhibiting if you want information on that. And registration for the conference itself, I think, is going to open in July. I'm just looking at my notes here. And we have also a lot of great other events. There's a Wednesday Mappy Hour, I think, that we do. And then there's a Thursday social that we're planning, a bunch of, I think also you mentioned your forum meeting is going to be on the Friday as well. So hopefully we get to see a lot of faces there. Thanks for the time, though.
Living in Atlantic City, there's lots of things happening there. There always seems to be a new thing that pops up. It's pretty crazy. It's hard to keep up with, that's for sure. Okay, last call for any announcements, anything? All right, well, thank you all for coming and for participating and for submitting. Please continue to support us, and we'll see you hopefully in October. Thank you. How about that? Like